Is water not a most miraculous substance? It makes up to 60% of our body by weight, up to 90% of other organisms' bodies by weight. It fills our every cell, it surrounds us as vapor in the air, it precipitates downward as nourishing rain or snow. It surrounds the continents in oceans where life began. It runs in rivers and collects in lakes with unique ecosystems. And it's just beautiful to look at. What gives water these special properties that make it essential to life on Earth? Well, water is a molecule, and in order to understand the properties of molecules, we need to understand the properties of the atoms therein. You will remember that atoms bond in order to become more stable until they have a full outer shell of electrons. That is, some atoms will bond, not the noble gases which already have full outer shells and are thus quite stable. But most other atoms will, and we can understand how molecules behave based on how badly the atoms inside those molecules want electrons to fill their outer shells. The halogens, for example, each have 7 electrons in their outer shell and just need one more in order to complete it and become stable. Therefore, they have a very strong pull for electrons. At the opposite end of the periodic table, the alkali metals have only 1 electron on the outside of their shells. Therefore, they're very eager to give up an electron. When this happens, 1 electron transfers from one particle to the other. We end up with oppositely charged particles that are attracted to each other, which end up forming an ionic bond, leaving the atoms stable. The atoms in the middle of the periodic table, coincidentally the ones that are most common inside organisms, don't have a strong enough pull to steal electrons, so they resort to sharing instead. And that's how molecules are formed. But inside molecules, sometimes sharing isn't caring. Oxygen is rather exceptional. You can see it's pretty buddy-buddy with fluorine right here, and fluorine is a very greedy atom. Oxygen is also a rather greedy atom, so it may share, but it doesn't always share equally. Oxygen is the central atom inside a water molecule, with 2 hydrogens attached. Now, this is a molecule, which means that there are electrons which are zooming around, being shared by, say, it hangs out near the oxygen atom, and then up it goes, zooming around the hydrogen atom, and down it goes by the oxygen atom, being shared, getting passed all around. But there's a bias. Oxygen has a stronger pull on those electrons than the hydrogens do. Sometimes I even call it an electron hog. Since it has such a strong pull on the electrons, even though it might be being shared, it spends most of its time down here, and then every so often, woo, up it might go, but most of its time down here, because that oxygen has such a strong pull on it. Now, if all the electrons are hanging out at one end of the molecule, that end becomes partially negative charged. That little delta means partially, so it's not a full charge, but since the electrons are hanging out down there, it does get a little negative. And on the other end, the protons that are left inside these hydrogen nuclei are now all naked and exposed. They're like, oh my gosh, where's my electron? It's no longer hanging out up here. Because, it used to be out here shielding that proton, but now it's just hanging out down here. So that means that the top half of the molecule ends up being slightly positively charged. So this bond between the oxygen and the hydrogen is known as a polar covalent bond. It has poles. It has a positive pole and it has a negative pole. And it makes the entire molecule polar. In other words, water molecules act just like little magnets. And you know very well you can take 2 magnets and line them up and their 2 ends will stick. Well, the same thing will happen with water molecules. Like you can see this water molecule in the center right here. Its hydrogen end has a partial positive charge, whereas the oxygen end of the next water molecule has a partial negative charge, and opposites attract, so boom, 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 those 2 molecules are attracted to each other. Now, this isn't a real covalent bond, these 2 molecules aren't sharing electrons, but they are attracted to each other, and so we give that attraction a special name. It's called a hydrogen bond, which honestly I think is the stupidest name for it, because it's not even a bond at all, but for whatever reason, the scientists decided to call it a hydrogen bond, and so we have to call it that too. So a hydrogen bond is just an attraction between 2 oppositely charged molecules. So hydrogen bonding can happen between two identical molecules, such as these two water molecules right here. It can also happen between one substance and another as long as they have opposite charges. So, for example, the glass over here of this graduated cylinder has some charges in it, and you can see from a macro level that the water is adhering to the side of the glass and forming this weird little shape called a meniscus, because right here at the corner the water molecules are attracted to and sticking to the walls. They're hydrogen bonding to it. So polar molecules can hydrogen bond with charged substances, either of the same molecule or of a different molecule.